All right, for section 9.1, we are going to start simplifying rational expressions. But the first thing that I want to get started with is this little bit of a factoring warm-up. It's going to be a very crucial part of this unit. And we should be pretty good with factoring, but I want to make sure that we kind of just recap it one more time. Okay, so go ahead and try these three on your own, and then we'll talk about it. So number one, what you can do is you could take out a GCF of 3x, and you'd be left with x plus 3. For number two, that is a 3-term, so we are going to t-chart. So first times last gives me 10, and 5 and 2 multiply up to 10, add to 7. We put our 1 and our variable in the denominator, and so we have x plus 5 and plus 2. Same thing happens on number 3 with the trinomial, right? First times last gives me 12. I need to multiply to 12, add to 7. That would be 4 and 3. And remember, we have our a and our variable in the denominator, so this time it would be a 6x. We actually can simplify both sides. The right becomes 2 over 3x. The left becomes 1 over 2x. And then we write it up. 3x plus 2, 2x plus 1. Okay, so what we're doing today is we are talking about rational functions, which basically mean fractions, okay? We're dealing with fractions now, right? And a rational function is any function in the form f of x equals p of x over q of x, where p and q are polynomials. So you're going to have variables in the numerator and denominator. So the first thing we need to talk about is just dividing things in general, right? So if we have something like 164 over 12, we can reduce that, right? And most of us would probably say, okay, well, we can reduce by 2, or maybe you notice that we can reduce by 4. The reason why you can reduce by 4 is because you can actually rewrite that as 4 times 41 over 4 times 3. And because you can do that, and because you have a 4 and a 4 in the numerator and denominator being multiplied, you can cancel them because 4 over 4 is 1. So you'd be left with 41 over 3 as a final answer. That's exactly what we're doing for the rest of the day today, except it gets a little bit more complicated than just numbers. So for example, here's our general idea of it. You have AC over BC. That means that you can cancel C divided by C, right? So let's use that with what we have down here. So this should feel pretty familiar because we keep coming back to it, right? If we have something like the numerator that we have here, okay, we have something raised to a power, a monomial raised to a power. That means that we're going to take our exponent and we are going to distribute it as an exponent to all of the numbers and letters inside. So 3 to the 5th actually turns out to be 243. Again, it's not 3 times 5, it's 3 times 3 times 3 times 3 times 3. And then we would have m to the 15th, n to the 20th. Our denominator can't change at all so far. And then we just need to reduce, right? 243 and 54. You can divide these by a pretty big number. And it might be just like a trial and error thing to you. And you could just keep reducing as you go. But essentially, if you start going, you might have more to do later. So you want to try to find the greatest common factor. And the greatest common factor between these two ends up being 27. So if I divide everything by 27, I would end up getting -9 because 243 divided by 27 is 9, and a +2 in the denominator. Now, you might be thinking, okay, wait, why did that turn negative? You can take this negative and you can put it wherever you'd like. I tend to just throw a negative on top if there is a negative in the fraction. Remember, -1/2 or -1/2 or -1/2, all the same thing, okay? So as long as you only have one negative somewhere, that's fine. So then you can look at your m's. Obviously, those cancel, right? M to the 15th over m to the 15th. Well, that's 1, so it's gone. Then we have n to the 20th over n to the 4th. We would subtract those exponents for n to the 16th in the numerator because that's where the larger one's at. So that should be something that feels pretty familiar to you because we have been doing that for a few chapters now. Now we're going to get into ones like number 5. This time, we're going to look at each individual piece and try to factor it and then cancel. Notice how I said that I can't just start crossing off, oh, x squared, x squared. This can become a 3 and this can become a 2 if we divide by 5. Okay, you can't do those things. All right, and the reason why is because this is not just x squared and x squared. This is 3x squared and 10x squared. So those are different and they're being added to multiple things. So you can only start canceling stuff when it's being multiplied, and you can only cancel a whole unit. And I'll keep saying that as we keep going. So what we want to do instead is factor the numerator. So then we have things that are being multiplied by each other. So I can take out a GCF of 3x, and I'm left with x plus 5. In my denominator, I can start factoring. I would take out a GCF of x squared first, and then we're left with x squared plus 7x plus 10. And that's a trinomial that we can factor. First times last gives me 10, and it would be 5 and 2 that multiply to 10, add to 7. So that denominator would become x squared, x plus 5, and x plus 2. Now is the time where you can start canceling things. You have x plus 5 in the numerator and denominator, so that becomes 1, so it cancels. The only other thing that you can simplify is x divided by x squared. Just like we had over here in this last one, right? We can simplify when we have the same variable in the numerator and denominator, as long as it's not being added to something else. So that would turn into just an x in the denominator. So we have 3 over x and then x plus 2. I don't want to distribute in because I want to keep it as simplified as possible. Let's get into a couple more examples like this. So on the next one, again, I can't just start canceling these units because they are just that. They're 1 unit of something that is 2 units long, right? This is not just x squared and 9, it's x squared minus 9. It's all connected. So instead, we need to factor it. So if I start to factor, this is the difference of squares. This is going to pop up very often right now. So we have the difference of squares, which means we take the square root. One's a plus, one's a minus. In our denominator, these are cubes. This is the sum of cubes. If you need to use the formula, feel free to look that up or have it with you while you're doing your homework for this, but hopefully we're starting to get more comfortable with it. Remember, we take the cubic root, so it's an x and a 3. Then we would square our first one, so x squared. Then we multiply the two of them, which would be a minus 3x. And then we square the last, which would be a plus 9. Now remember, these specific things are from the formula, so this is always a plus minus plus if you start with a plus. Remember, if this was a minus in the original, then it would be minus plus plus. So now we can start canceling now that we have things that are being multiplied. So at this point, you notice x plus 3 goes away, and we're left with just this. Now you might be thinking, wait a minute, shouldn't I try to factor this? Hopefully you remember anytime that you do a difference or sum of cubes, this trinomial is actually prime. So if you were to try and factor it, you would say what multiplies to 9 adds to negative 3, and you would get nowhere. So then we have number 7. All right, this time we go straight into trying to factor it, right? Again, I can't just say, ooh, these match, they go away. Oh, there's an x and an x, there's a 10. My answer is negative 1 over 11. Okay, That doesn't work because they're not being multiplied, they're being added. So we need to get it to be where we have things that are being multiplied. So we can t-chart that top part. This gives me negative 30 when we do first times last. And what multiplies to negative 30 adds to negative 1. That would be negative 6 and 5. And we put a 3 and an x in the denominator. This time, the left side cancels. We get a negative 2 and an x. So our numerator right now is x minus 2 and 3x plus 5. Our denominator can also be factored. First times last gives me positive 30, and now we need a positive 11. Well, that would still be 6 and 5. Again, the left side can be reduced. So we now have our denominator as x plus 2 and 3x plus 5. Now, obviously the 3x plus 5's cancel, but the other two do not because one's a plus and one's a minus. So we can't start canceling everything and say our answer is negative 1 because they're not being multiplied, they're just being added on the inside. So that is our final answer. So now let's talk about what makes something undefined. Something becomes undefined because there's a specific thing that we can't divide by. We can never divide by 0. So that means that anytime we have any functions like what we have had so far, the denominator can't be 0. Because if it did, you'd be dividing by 0, which you can't do. To find the undefined values of a function, factor the denominator and set each factor into equal to 0 and solve for that variable. So for example, on number 8, what we would do is we would have to look at our denominator and try to factor it. If we t-chart this, first times last is negative 27, and we would have negative 9 and positive 3 to add up to negative 6. So our denominator would be x minus 9 and x plus 3. So my undefined terms would be where x minus 9 equals 0 and where x plus 3 equals 0. In other words, x cannot equal 9 or negative 3. Because if they equaled 9 or negative 3, this would then be a 0, which would make this undefined. So let's go ahead and do that for the last 3. In the first one, it's really nice. It's already factored for us. So that means that x plus 1 equals 0, and x would not be able to equal negative 1. And the next one would be 2x minus 3 equals 0. So if we solve, we get 3 over 2, which means x cannot equal 3 over 2. Number 10, we would have to factor first. If you factor, first times last is negative 12. And two numbers that multiply to negative 12 add to negative 1 would be negative 4 and 3. So if x minus 4 and x plus 3 are in our denominator, that means x cannot equal positive 4 and negative 3. Now the last one's not something that you see often, but I do want to get you to start thinking about ones like this. Think about all the things that are in the denominator here. Well, there's a fraction within a fraction. So first off, let's think about the big fraction, right? You have numerator, you have denominator. So both of these pieces down here need to be set equal to 0 because they are currently in a denominator. The only other thing that we need to think about is we also have a denominator in the numerator. So now if we solve, that means that x cannot equal, in the first one, a negative 3/2. In the second one, it would be 4. And in the last one, it would be 0.